Beneath the tranquil surface of Italy's Campi Flegrei, a restless giant stirs. Solfatara, a seemingly dormant volcano, is spewing more gas than ever before. But what if these increased emissions aren't just normal volcanic activity? What if they're a warning sign, a whisper of something far more catastrophic lurking beneath? Solfatara, with its sulfurous fumes, bubbling mud pits, and constant geological activity, has long been a source of fascination and concern for scientists. Situated near the bustling city of Naples, Italy, this active volcanic crater is part of the Campi Flegrei caldera, one of the most dangerous and unpredictable volcanic regions in the world. Over the past few years, data has shown a notable increase in gas emissions from Solfatara, particularly carbon dioxide and sulfur dioxide. These emissions, while not immediately alarming, are raising questions among geologists. Could they be an early warning of a much larger, potentially catastrophic event? In this video, we'll dive into the geological significance of Solfatara's increasing gas emissions. We'll explore whether these emissions are just part of the regular volcanic cycle or a precursor to a more serious geological event. Is Solfatara signaling that a much bigger eruption might be on the horizon? Let's uncover the mystery of this volatile volcanic system and examine the risks that lie beneath. Welcome to the Flegreian Fields, one of the most active and potentially dangerous volcanic regions on Earth. The Flegreian Fields, or Campi Flegrei, are located just west of the Bay of Naples, and they form a vast caldera that has been shaped by repeated volcanic activity over tens of thousands of years. Within this caldera lies Solfatara, a seemingly calm and dormant volcano that has been quietly emitting gases and heat for centuries. But despite its outward calm, Solfatara is far from inactive. While it might not be erupting with the explosive violence of Mount Vesuvius, which destroyed Pompeii in 79 AD, Solfatara's activity is no less significant. Over the years, Solfatara has emitted large quantities of gases, such as carbon dioxide, sulfur dioxide, and steam, which have become characteristic of the area. These emissions are an indication of ongoing geothermal activity beneath the surface. But what makes this more concerning is the noticeable increase in gas release over the past decade. The question now being asked by geologists is whether this surge in gas emissions signals a deeper, more unsettling shift in the behavior of the caldera. Increased gas emissions can indicate a rise in volcanic activity, including the potential for magma movement or pressure building beneath the surface. For scientists studying this region, the rise in emissions is a cause for concern, one that might signal that something far larger is stirring beneath the surface. But are these gas releases a normal part of the volcanic cycle, or are they the early warning signs of a larger eruption that could threaten the surrounding area? To answer that, we need to understand the nature of Solfatara's activity, the gases being released, and what their increased presence means for the future of the region. The primary gases being emitted from Solfatara are carbon dioxide, CO2, and sulfur dioxide, SO2, both of which are commonly associated with volcanic activity. These gases are produced by the heat and pressure beneath the Earth's surface, which causes the release of gases trapped in the magma and surrounding rock. In the case of Solfatara, the increase in emissions, particularly CO2, has become noticeable, and the data is raising alarm bells among scientists. Carbon dioxide, a colorless and odorless gas, is particularly concerning because it is heavier than air and can accumulate in low-lying areas, creating hazardous conditions for both the environment and human populations. Sulfur dioxide, on the other hand, has a pungent odor and can contribute to acid rain, causing environmental damage to vegetation, water bodies, and infrastructure. Both gases are associated with volcanic systems, and their release is often a sign of geothermal activity or magma movement beneath the surface. Increased CO2 emissions in particular have been observed in many volcanic systems as a precursor to volcanic eruptions. When magma rises toward the surface, it can bring more gases, including CO2, with it. If the pressure in the magma chamber increases, it can cause the gases to escape more rapidly, leading to higher levels of gas emissions. This process is often associated with volcanic unrest, and while it doesn't always result in an eruption, it can be a sign that the system is becoming more active and that conditions are changing beneath the surface. In the case of Solfatara, the increase in gas emissions has been linked to rising temperatures and changes in the behavior of the fumaroles, the vents through which gas and steam escape. These changes could suggest that the region is experiencing increased volcanic activity, possibly signaling that the system is becoming more volatile. The idea that gas emissions from a seemingly dormant volcano like Solfatara could signal something much larger is not as far-fetched as it might seem. Volcanic systems, particularly those in active calderas like Campi Flegrei, are highly dynamic. The release of gases is just one of the signs that scientists look for when assessing the risk of an impending eruption. As magma rises to the surface, it can begin to heat the surrounding rock and create pressure in the crust. This pressure causes the rock to fracture, creating new pathways for gas to escape. When these fractures occur, they can lead to an increase in volcanic tremors or even larger seismic activity. Gas emissions are often accompanied by other signs, such as ground deformation, changes in temperature, and increased seismic activity, all of which have been observed around Solfatara in recent years. Increased emissions of carbon dioxide and sulfur dioxide can lead to changes in the ground's behavior. The heat beneath the surface, combined with the pressure of the gases, can cause the ground to crack and shift. This ground deformation is a warning sign that the crust is under stress. Over time, these small shifts can build up and trigger a much larger event, such as an explosive volcanic eruption or even a caldera collapse. In the case of Campi Flegrei, the threat is particularly serious because the caldera is not just an isolated volcano, it is a massive geological feature, one of the largest and most dangerous volcanic systems in the world. The last major eruption of Campi Flegrei occurred around 39,000 years ago, and although the area has experienced smaller eruptions since then, the potential for another major eruption exists. The increasing gas emissions from Solfatara, combined with the region's complex history of activity, have prompted geologists to take a closer look at the risks associated with the caldera. If Solfatara's gas emissions are indeed signaling increased volcanic activity, the implications for the surrounding region could be catastrophic. Naples, a city of nearly 3 million people, lies just a few miles from Solfatara. The threat of a major eruption or caldera collapse is real, and the consequences for the city and its surrounding areas could be devastating. A large eruption could result in widespread ashfall, pyroclastic flows, and volcanic gases that would cause widespread damage to infrastructure, agriculture, and human health. The sulfur dioxide emitted by Solfatara has the potential to cause acid rain, which could damage crops, contaminate water supplies, and harm the environment. Furthermore, the CO2 emissions, while less directly hazardous in small quantities, could pose a significant risk to human life if they accumulate in low-lying areas, leading to suffocation or poisoning. In addition to the immediate effects of an eruption, the long-term consequences of a volcanic event in the Campi Flegrei region could be profound. The volcanic ash and gases released into the atmosphere could have a global impact, potentially affecting the climate. Previous eruptions in the region have been linked to temporary global cooling, as the particulate matter in the atmosphere blocks sunlight. Given the potential risks associated with increased gas emissions, scientists are closely monitoring Solfatara and the surrounding Campi Flegrei caldera. Advances in technology have made it possible to track volcanic activity with greater precision, using a combination of ground-based sensors, satellites, and remote monitoring systems to gather data on gas emissions, seismic activity, and ground deformation. By measuring the concentration of gases like CO2 and SO2, scientists can track changes in the volcanic system over time. They also use ground deformation measurements to detect any shifts in the Earth's surface, which could indicate the movement of magma beneath the surface. The use of thermal cameras and remote sensing technology also allows scientists to track changes in temperature, which can indicate increased geothermal activity. All of this data is then analyzed to assess the likelihood of a major eruption or other geological event. By identifying patterns in the emissions and ground behavior, scientists can issue warnings and help local authorities prepare for potential risks. In addition, the knowledge gained from monitoring Solfatara and other active volcanic systems helps to improve our understanding of volcanic processes, contributing to a broader knowledge of Earth's geology and hazards. While the risks associated with Solfatara's increasing gas emissions are real, the good news is that we have the tools and knowledge to mitigate the damage and prepare for the worst-case scenario. As scientists continue to monitor the region, there are several key steps that can be taken to ensure the safety of people living near Solfatara and the Campi Flegrei caldera. One of the most important actions is early warning systems. By using real-time data to track changes in gas emissions, seismic activity, and ground deformation, authorities can issue early warnings to local populations, allowing them to evacuate if necessary. This early warning system could save countless lives and minimize the destruction caused by an eruption. Additionally, building resilient infrastructure in high-risk areas can help to mitigate the impact of volcanic events. For example, designing buildings and roads that can withstand seismic activity and ashfall is essential in protecting vulnerable communities. Public education and preparedness programs can also help residents understand the risks and take the necessary precautions. The increasing gas emissions from Solfatara are a sign that the earth beneath our feet is anything but stable. While this volcanic system may seem dormant, it is clear that it is far from inactive. Whether these emissions are part of a natural cycle or a sign of something more ominous, the truth is that the potential for a catastrophic event in Campi Flegrei cannot be ignored. By studying Solfatara and the surrounding region, scientists are uncovering the mysteries of this volatile landscape and helping to prepare for a future where the threat of volcanic activity looms large. As the Earth continues to shift beneath our feet, we must remain vigilant, understanding that the forces of nature are always at work, often in ways we can't predict. Are we ready for the quiet storm that might be brewing beneath Solfatara? Time will tell, but one thing is certain: the volcanoes